I pledge allegiance
to the flag of the United States of America,
and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Lon?
Sure. Dear Heavenly Father, we come to you and just thank you for all the safety that you've given us, and we ask for your hand and protection over each and every mission that Civil Air Patrol flies. And thank you for our family and supporting us in these operations. And be with our military men and women that are out there serving our country. Be with our leadership to give them guidance and wisdom, we pray. Amen.
Amen. Thank you, Lon. Everybody, hey Bob, you know, you, for a lot of times you told me to wait for you until you stood up and got out of your chair, and so I've gotten the habit to do that, but now you're not waiting for me.
I just started extra early, I'm sorry.
Yeah,
I
you're
thought
like a
you were doing
rambunctious
it. I was
there.
trying to be in unison with you, so it didn't
Yeah.
work out.
That's all right, I'm just teasing you, so.
And I'll take your birthday away.
Huh?
I'll take your birthday away.
Maybe
So-
we could ask
What's that?
Andre.
What's that?
You've flown Zelda before, right?
Yeah.
Okay. Hey, do you remember the power of the voltage and the amperage on the engine screen when you just first turn the battery bus on? It's showing a negative amperage, like
Well,
7 amp discharge. Voltage is
Did you
23.
you took a video of that today?
Yeah,
Why don't you play it?
okay, it's pretty long.
We'll just play part of it.
Okay.
Well, I mean, we just wanna
Yeah.
go over the, maybe Bob might know a little bit about it, or anybody in here. might know.
Here's the question behind all that we're gonna talk about, is that the external power supply, when you plug it into the plane, and you turn it on, it looks like the external amperage meter goes up to, what, 3-4 volts? Amps, I
3 or
mean,
4 amps, yeah.
something like that, without any draw from the aircraft at all. It's just plugged in. Okay, when you leave the switch on, and when you get in the airplane and you turn the battery bus on the engine monitor screen, it shows the voltage and the amperage. Well, the voltage is like 23, 24 volts right in there. When you turn the external power unit off, the
On.
voltage,
When you turn it on,
no, it's on, we started with it on.
oh, we started with that, I'm sorry.
Okay, and so now it's reading like 23.5 volts, and when you turn it off, it starts to drain, but it's like 1/10 of a volt, not a lot, but so you turn it back on, and then it stabilizes the voltage, but it's still it's showing a discharge of like 7 amps, and our question is, okay, with the external power unit plugged in, shouldn't it be like 0? Because it's supposed to keep up with the load that's being demanded.
there could be a relay whereby the power switch powers the system, but as soon as you turn your power off, you're deleting the external power to it. You can't have both of them running at the same time. So what you've got when you turn it on, you're powering it off your battery bus from the battery in the aircraft. Whereby in the Bonanza, everything stays off until you get everything started, and then you turn everything back on because there's diodes in there that you can burn out. So I'm just looking at what I've had in my experience in the past. There should be a relay that may be in there. You'd have to look at the schematics. So that when you have this turned in, when you have the external in there, it's powering the system. But as soon as I turn the power on in here, I can't have two powering the same buses. So the relay kicks the external off to run the internal.
So you're saying when you turn the master on, then it disconnects the power supply.
To a relay. I'm suspecting that's what's happening.
There's a relay, and we can look at it. I have the schematic for it. I can bring that up here.
Yeah.
But the problem with that, Bob, is what happens, what we're doing right now is when we turn the master on, then we get the voltage going through to the voltmeter, and the voltmeter shows positive volts with the external power on, correct?
The volts show
Yeah,
positive.
but it
yes.
shows a 7 amp discharge at the same time.
And
So,
here's, let me add something also right at this point,
yeah,
is that if that be the case, then there's no way that you could use the external power unit to power your avionics for like 3 hours, sit in there and do, button work.
Put the master on.
Screen, yeah. Okay, you gotta turn your master on in order to get your G500 to work.
right. Now, I do know that there's 2 ways that they wire the external power. 2 ways that Cessna does, because one way is the way that the 437 is done. So when you plug in the external power, it powers up the G1000 environment, and we run off of the external power. Because it shows about an 8 or 9 or 10 amp load on it, on the power supply. The thing like my Skymaster used to be, if you plug something in there, it would not, the avionics wouldn't come on, nothing would come on inside. So you plug your external power in, you start the engine, unplug the power, and then it'll go down to all the other gauges. So that was weird, wired kind of weird on my Skymaster. So there's a couple of ways they can wire these, and I'm not entirely sure what's going on. We may have to take the aircraft, Zelda, to an avionics company and say, hey, check this out and see if it's
Now,
working right.
The other thing too is that
But I'd like to call somebody first and say, hey, these are our symptoms, what do you think?
if can you turn off the Garmin 1000 independently?
Well, we don't have a 1000, but we have a G600. Yeah, you can turn it off independently.
So look at the amperage and turn the equipment off one at a time and
Yeah.
watch what happens.
Yeah, I can see it. I can
Because
see it
then what you're
decrease.
doing, you're beginning to isolate where your draw is.
Right.
If you got everything on, you have no idea what's causing the draw, except there's power and avionics. So,
Well, every piece has a piece of draw.
but if you're looking at 24 volts and you turn on the Garmin 5 or 600, whatever it is,
Yeah.
it's going to have probably, I'm just going to say each unit may even draw 3 amps.
Couple amps, yeah.
So,
Well, when you turn the avionics switch on, it goes from 7 amps to 10 amps.
Load.
Load drop. Negative. And we can look at the video here in a little bit, but I have the schematic up now. If I can get this thing off. There.
so where's the external?
Now, this is the original schematics for
It's
the
about halfway in
original
the screen.
aircraft.
Yeah, this was
Okay, I
from the
see it.
pilot operating.
I can see it. So you see, you've got.
That fuse, Mike, you wanna point out the fuse that you
Hey,
changed?
where'd my pointer go? Anybody know where my pointer went? It was there before the Sarex, and now it's not there. By the way, does anybody have my cap grid chart? Any chance?
But I think you're onto something, Bob, when you're talking about the relay. That's what I was thinking at first too, is
Yeah.
that some relay is not working properly.
See, but the only thing you've got is this polarity contactor in between the contact and the battery bus.
Ground.
Can you drop it down a little bit? So, see, the battery's feeding the contactor, so you're getting amperage draw here, we know that. Well,
Here you go,
pressure
Bob.
switch. So, the battery's feeding the battery contactor, so when the battery switch, we should switch, I don't see the battery switch.
The master switch is a little bit higher in the schematic there. See it up atop?
Upper left.
Yeah. See, when you turn that switch on,
Yeah,
it,
see what's happening here?
it powers the primary bus.
But see, you got all of these things here being powered. You got this one here and the starter contactor. This thing takes a lot of power. And then so if this is showing it's there because you haven't operated the start switch, this is gonna be drawing power, that's gonna be drawing power.
And see, the amp
And this
meter,
is running
the
off
amp meter
everything
should
down
read
here.
all this load. If you turn everything on, the amp meter is gonna read this load when you got the
That's
switch
right.
on. However, what he's saying is, when you plug in the the power supply here, it should compensate and it should be equal. It should put enough power and amperage in, so this is zero.
Yeah,
That's
right.
what, that's what we're
A little
saying.
bit lower from that, there's a fuse, right above that, Bob, right there, that fuse. Mike changed that, that was blown the other day,
Yeah,
See, cause you got a one-way diode here,
yeah,
you got a one-way diode here, so the power can only go one way.
right.
And it feeds the battery contactor, which says it's feeding, this up here. It's gonna feed this, and it's also gonna feed
any electronics experts in here?
here, because this is one way, so it's feeding here, and that's gonna keep this closed.
I
I
think,
just say it's, you may find by just turn this thing on and then start down and see what you've got. This one here takes an awful lot of power. That one there,
well, we know that the avionics bus, which is down here,
yeah, don't blow it.
yeah, it takes 3 amps on its own, right? Goes from 7 to 10.
See, and this is gonna take power, but it's not electronic.
Yeah, well, we
It's not
don't have that
very
on
big.
right now. We don't have any of the lights on. So the only thing that are on are the radio, transponder, cap radio, things like that.
Well,
So,
if you just, even at 14 volts, the average radio, which is 11 to 14 volts, is gonna be pulling,
well, remember, it's a 24-volt system.
I understand that. You're gonna be pulling 1 to 2 amps depending upon the radios themselves. I mean, that's just normal, because even though they're electronic, you gotta feed the power supply to it, so it's gonna take amperage. I just say, the easy way to isolate maybe is to go through the circuit breakers, pull them out, and watch your amp meter go, and see what happens. Because I think you can isolate it.
Well-
If you pull a circuit breaker from that bus
Yeah.
bar,
Yeah,
you notice it's being fed in 3 different
But
sections.
Bob, what do you think the problem is? I mean, what do you hear us saying as a problem?
I just
Because I
look
think
at
you're
the-
on the wrong tangent myself.
On a relay?
Well, it might be a relay, but the thing of it is,
How do you know
there-
if you got something that's failing,
yeah.
and therefore it's drawing more power to make up that differential that has to feed some form of avionics?
Don't know.
See?
Don't know, but I have done what you're saying. I've turned every piece of equipment off one at a time. I didn't log it, but I watched the amperage, the load go down last time I was playing with it. Before London, I got to play with it today, so. But,
This thing right there, that thing is only covering, that's less than an amp.
yeah, but look at
Oh, that
this.
one
No,
there.
no, no, look at this, see? Amps, 7.9,
Yeah,
and that voltage is 25.3.
well, that's fine,
So that's
normal,
That's
Yeah.
that's our load. Is that normal to see that indication?
yeah.
When it's not starting?
but
Well,
it's
it's been
flashing
turning.
too.
Yeah, but what I'm saying is when we plug the power supply in, shouldn't this go to 0? Because the power supply is supposed to be supplying the amps and the volts it needs to
But
function.
how do you know,
Plus that voltage is flashing yellow. There's something wrong there, it's advising you that.
Yeah, I don't know what
I'd
flashing
have to
means.
reread.
It is actually dropping because now it's 24/7,
And 10 amps.
24.
Oh, that's when we turned the avionics.
Remember, Mike,
Don't
when we were
forget,
playing with it the other day, we had the same problem.
We ran the battery down because we thought that the.
We thought the power supply was compensating, and it
covered
was
it
not.
was not.
Yeah.
but
Yeah.
that blinking can show that you've got a draw on the battery and you don't have the engine started. I don't know how
But see-
this thing works.
See, I kind of have the same, I agree with you a little bit, that it might be showing the load before the engine starts.
Yeah,
However, with the power supply plugged in, if I do that in 437, all that goes to 0 in 437 with that power supply.
and it could be bad wiring too in there.
Well, there's something might be wrong
Don't
in
forget
this,
that whole thing,
in this device, there might be something wrong in this device, like maybe there's a fuse blown, or maybe
No,
there's
I
a
don't
program
think-
setting this incorrect, or, go ahead.
Should we be able to program the avionics in the hangar off of the power supply? That's what we would like to achieve, isn't it?
Well, that's what we'd like to achieve. That's what we're trying to find out, if this is wired to do that or we shouldn't be doing that.
Yeah,
We've always been told that it's supposed to do that.
What we're trying to determine
Yeah.
is, can I sit in that cockpit for 2 hours
I
and
just said
run
that.
the avionics
I just said
with the
that.
power supply turned on and not worry about draining the battery?
Right, that's what we just said. I mean, in
Yeah.
a different way, you know.
Is the yellow light on down below showing the voltage meter?
This one?
It's under voltage, yeah.
Is anybody
the engine's
online
not started.
that,
It looks like I have Tim Peterson,
Yeah, Tim,
but he's not saying anything.
Oh.
He's just.
okay, thank you.
See, but
Hi, Tim.
don't forget, Zelda was back on the East Coast for like almost a year, 9 months to a year because they were cheap. Just remember, they were cheap. And there was nothing but issues in regards to getting that airplane back from that contractor. So, you know, is it 50-50 that there's something wrong with the wiring, the way they did it? Who knows?
See, I'm gonna have to, like I said, I'm gonna have to get the wiring diagram of that unit and see, basically, and then talk to their tech support and find out basically how that's supposed to be reacting
Yeah.
with a power supply plugged in.
Is that-
And maybe we don't have the luxury of plugging the power supply in and running it and
Okay,
training
what the
on
hell-
it.
What good is the power supply then?
Starting the
Charge
engine.
the
Well,
battery.
the power supply was purchased for 437 and it
No,
works
no, no.
fine in
The
437.
design of that plane back in 1980, or probably
Yeah.
75 when it was
Right.
designed, but they put a receptacle in there for a reason.
Yeah, but that's not the same equipment that was in there in 1965 or whatever it is, 73.
True, but it should still have the
Is-
same
is-
function.
Is the engine
No,
mon-
I disagree.
is the engine monitor a Garmin?
What's that?
Is the engine monitor a Garmin?
What,
No, no, no.
What makes that?
This is, I think, ECI. Quit moving it.
Hands off.
That guy with the camera, he's trying to make me sick. I think that says ECI up there in the corner.
It's a
but-
good unit, it's a good unit.
Huh?
They're here local, I think.
Oh, there it is.
It's probably the end of the video.
Yeah, I think that says ECI, but I'm not positive. But it's an MEP 50, we can look that up. So,
I think you can even get the installation on it, but they should be following the.
well, yeah, I mean, I can call an avionics company and say, hey,
Well, you can probably call those people. I'd start with ECI.
I'd start with
They have
them
a good
too.
tech rep, they have good tech reps there at the
Yeah.
company. I've called them, in fact, I put in ECI units in all my T-34s, for the tachometers.
Right.
Because they were clocks and they gave me true time and flight time. They have good tech representatives there, and tell them what you've got, and you can't understand, and then give them the issue that when you plug in external power on this Cessna, that we see the voltage start out at 25.3, which means it's charged, and the amperage is at 7.7, and it continues to drain to 10 and 24 volts
with the power supply plugged in.
with the power supply plugged in.
Alon, you wanna head that up, or should I call them and do the calls?
You can make a call. I can make a call.
Choose one.
Go ahead.
Okay. Then I'll do that.
I got one more question.
Yeah.
If your battery's low and everything's turned off and you plug in the external power supply, will it charge the battery?
Actually, it does. If everything's turned off inside. It does put voltage to the battery. I verified that with a volt ohm meter, so.
So maybe it doesn't give enough current to charge
Yeah.
and
But here's the kicker. I mean, it is a 30 amp charger. It'll charge 30 amps.
that's a lot.
So if it needs 30 amps, it should be pumping it right in there. But it's not. It goes to about 3, maybe 4 amps and it stops right there. So,
Maybe that's telling you the truth. The only way you can check on the meter is to take and run a pigtail. You're gonna have some heavy wire to the terminals, and then put an amp meter across it to see if it's what it's feeding.
put an external amp meter to see, to verify it. But see, I'm with Valon. I think there's still something wrong in the logic of the wiring.
Yeah,
You know,
probably,
but we're trying to figure out where to start.
Yeah, and there's been no quote-unquote discrepancies or write-ups that
No.
we know about
That we know
this
about, no.
subject.
And maybe nobody had a power supply to plug in there, or maybe nobody cared about plugging it in and doing any training on it at all.
Right.
You know, and we're just the first ones doing that, so.
Oh, one more question.
Go ahead.
Let's say that the batteries discharge significantly,
Right,
and we wanna start the engine this time.
well, you can't.
If
If the voltmeter, it's been my experience, that if the voltmeter reads less than 20 volts, it won't start.
Okay, but I'm saying.
Doesn't have enough oomph to get it
You
started.
plug in the external power,
Yeah.
and everything else is off, you still can't, and the battery's
The
discharged.
the external power supply is not a battery replacement,
Got it.
okay?
So
It's
all you
not
do
meant
is-
to do that.
Charge it over time.
If you had a battery, what do you call it? A booster, where it's a 24 volt
Yeah.
battery with battery cables into there, different story. You could start the engine off of that,
Got it.
because it's got enough amps for that. But that little charger only has 30 amps, right?
See,
At a full
got-
load.
You gotta have power to close your relays. That's the key to any of the
Yeah.
starting.
Yeah, but it's got 4 or 5 amps showing on it, load. And it's showing, 24 volts,
'Cause I can-
or 32 volts actually.
In the T41s that I had, and the 182 that I had, which came out of Arizona, it was CAP,
Mhm.
it was a 182. If the battery got down to a point and it would just go,
Right,
and you plug in external, if I remember right,
yeah.
it still would go, until the battery came up to
If
Pacific.
you plugged in, hypothetically, if you plugged in the power supply and walked away for 2 hours and came back, there may have be enough power in there to start the engine.
Yep.
There may be.
Charged.
Well, because there is voltage going to the battery, I verified that. So that means it is going there.
Yeah, you charged it
I'm
back
just-
up.
And you're charging it at like 1 amp per hour or whatever it is, but yeah, you most likely could get it back to starting condition, but it might take a while.
Does the book call for you to turn on the master switch when you start the engine with the external power? Because in the Bonanza, if you do that, you start it without the master on.
Yeah.
and then they
Remember,
will-
You need-
it's
because-
not a starting charger. It's not meant to do that. It's only a battery eliminator for the gauges.
Oh, what I'm saying though is that,
Bob, to answer your question, you need the battery on
okay,
so that your G500 comes up and your engine analyzer comes up so you can see whether you have oil pressure and all that.
Yes, sir.
I got a question. I haven't played the G1000, but aren't you supposed to arm the standby battery before?
That's the G1000. There is no standby battery
Oh,
in this
just
plane.
regular
Not in
Garmin.
Zelda.
Just
Yeah.
regular Garmin. That's right. That's right.
So, we have a dilemma. I have to do some checking with the manufacturers and see how they recommend it working, and maybe it's defective. Because
do
when
another
the
one.
fuse, listen, when the fuse blew out, that means there's something wrong.
Yeah.
So,
it's an overdraw.
yeah, so I put a new fuse in, I had the battery charged by the mechanics, they took the battery out, took it down, charged it, put it back in, so it's done professionally. And that was a couple weeks ago, by the way, so.
Is the
But
fuse still
I'm
good
just
now?
trying to eliminate that happening again. So we're trying to figure out how it works exactly.
Well, I missed the
Sir?
first part. I missed the first part. What are we looking at? Just you have a question about the engine monitor, or?
Well, no,
In summary,
but it's in summary, yeah, the engine monitor, yeah.
we're trying to find out whether or not the external power unit is given any, is powering the aircraft so that you can sit in the cockpit for 2 hours and not worry about the battery draining. It appears in this video that we took and all that it's discharging at 7 amps, when you turn the battery switch on.
Yeah.
And with the external power, you would think that it would at least be at 0 to compensate for that.
Unless, you said it's a battery tender that's plugging into it, right?
It's a battery, basically a battery eliminator. It's not a battery charger. It's not supposed to be a battery charger. It's not supposed to be a battery start cart either.
Right.
But
Yeah.
these external power units were bought specifically to do what we wanna do, and that's plug it into the plane.
Right.
So that you could sit in the plane and not drain the battery.
Right,
Right.
so that would mean it should be
But-
able to put out 24
It's
volts.
But Lon, it may not work for this particular configuration. It may work
Yeah.
perfectly for 437, but it may not work for this configuration. And that's what we gotta find out. You know,
Well, that's in summary what we're trying to do.
remember the ECI is a replacement unit for all the round gauges that used to be in there. And the G600 is a replacement, and it's just an upgrade. It's a hybrid, so will it work exactly the way we want? Maybe not.
See where that starter contactor is? On to the right side of it, that wire that goes all the way down,
This
if
one?
that was broken, no, keep going up. Up,
Up to the left, upper left-hand corner.
Yeah, that, up,
Never,
that one there, if that wire was broken somehow or not,
that's the input.
then the power would not be getting to the primary bus from the ground service
Well,
receptacle.
but that wire that you're pointing out, that's from the battery to the starter, right?
Are you a
No,
schematics guy?
it's connected, it's connected to the external power supply. The wire that runs through that relay, the reverse polarity contactor, that power is running to that wire that goes to the same connection point down at the battery contactor. And then it goes up to the starter contactor and then over to the amp meter.
See, that's the positive. That's the
Yeah,
positive.
that's the positive.
And what's the one on, and then the other is the positive coming off the other side of the relay going to the starter. Because the starter's going to ground, so that's positive. But what's the one that goes on the left-hand side of the contactor, starter contactor, where's that connected? It goes down to, further down. You gotta move up here. So it's going to,
The switch,
it says instrument circuit breaker.
yeah, instrument circuit breaker gives power to the switch so that you can actually start the starter.
That's right, because you see, it's going to the positive side,
Yeah,
positive side of the solenoid. And the solenoid's closed. So when the solenoid's closed, then you're gonna read it from amperage, because it's feeding off that amperage back to the battery bus. Or the main bus, whatever, that's the battery bus.
So
well,
anyway,
we'll make some calls, I can call Tom.
that's our dilemma, and what's
I can call Tom also and see if he has any history there.
Tom Charpentier,
Yeah,
possibly.
I get along with him
Yeah.
over the phone anyway.
Well, he might be able to tell you if you plug in the power supply if it works that way, or it did used to
Exactly,
work that way.
I mean, he's,
Yeah.
they've had the plane for
Give him a call.
a pretty while.
Yeah. So anyway, I'm sure that everybody wants to know the condition of my health, and instead of telling it 15 times, I just tell it once. So what's going on is in 2013 I had a quadruple bypass, which is 4 arteries, and they bypassed the 4 arteries. A year later, one of my bypasses collapsed, so it just collapsed, and they went in and they put some stents in that artery. So basically, they had an artery like this, and they put a stent in here, something like that, and they blew it up, and they made the artery that used to look like this with a restriction, right? Plaque, of course. They blew it up and they put one stent in it. That was in 2014. Well, my body attacked the stent material with scar tissue, so it's called stenosis. So it came in here and it did this and put scar tissue in there, and now it's restricted again. So what the doctors did is they put a second layer of stents in to get rid of that, right? So now I got 2 sets of stents and 1 artery to make it open again. Well, after about a year, so 2014, 2015, my body plugged that up again and restricted it again, right? So they went in and they put a 3rd set of stents in, 3 layers to open that up. Pretty good. At least I was getting blood to everywhere and everything was fine. Well, my body again attacked that, and now it's completely plugged up. But now they're telling me they can't put anything else in there. So what do? Well, it's got a restriction, and the body, I found out from one of the doctors, that the body actually doesn't like these restrictions, so it makes its own bypass. It's very small bypasses. Your body makes those to get oxygen past this restriction. So right now, that's what I have. I've got these small, body-made
Capillaries like?
capillary type veins going just enough to get the oxygen in there so it lives, right? That's why when I try to do anything, I run out of oxygen and I start breathing hard and trying to get air and things like that. So right now, this is my condition. Now, they've checked all the other arteries and all the other bypasses are open and clear and they're working. The other 3, which is good news, because I only have 1 problem. Now, the only way that I can see to fix that without consultation yet is that they have to open up my chest again, go in, cut this out, or put another bypass from this one over here that's a substantial size, which is what they do is they pull a vein out of your leg, and then they attach it here, and they attach it there, and they throw the rest away. So, to make this substantial oxygen going around, right? So that's my condition right now, which means I'm limited to what I do. And I have a problem when I fly. If I get over 3,000 or 4,000 feet, I gasp for air and I can't breathe very well. So I'm gonna have to stop flying completely, just for health reasons and safety reasons. So that's what's going on with my body right now. Whether they can fix that or not, I don't know. I can't believe that they can't fix it, they just may not want to fix it. So, I don't think they can actually cut the old stents out of there and just sew it together. That's what I would say to do as a plumber, you know. Cut the rust out, put a piece in there, and it works fine. I don't know if they can do that or not. So my appointment for my cardiologist is in about a week, and we're gonna discuss all that. If I get a new bypass surgery, I won't be here for months, so it takes a while to.
I mentioned
Remember that.
last week or so,
What's that?
Ajax, the guy that used to work on infant hearts
Yeah,
through mirrors and
I
tubes.
know Ajaz, yeah.
Just even having a chit chat with him.
Oh, yeah, that's a good idea. Actually, we're
You're
we're
getting-
very good friends. We used to fly his airplane
Yeah,
to lots of
but
places.
that's all he does. Of course, he works with infants,
Right.
and if he's, you know, a good doctor in regards to the heart,
Yeah,
he'll give you some different opinions to help you make a decision where you wanna go,
yeah.
versus relying upon your one doctor. I'm just doing it, that's what I do.
Well, I'm gonna see what my doctor has to say, my cardiologist. He's pretty good, actually. But yeah, a second opinion is worth $1 million right now, to me. Because I can't do much until something gets fixed.
It's like my knee surgery, I canceled the operation after I talked to the guy across the street, the doctor across the street.
Yeah.
He says, don't do it. Don't do it right now. He says, when you can't walk, then he says, you may want to consider it. But he says, you're still in good health and you're still walking and you can still climb ladders and you can do all that stuff. And he says, well, Donaldson's an awful good doctor. But he says, my opinion, if it was me, I'd bypass it, and that's just what
I had knee surgery about 25 or 30 years ago, and it was the greatest thing I did because it had been pretty much messed up for 20 years prior. When I was 20 years old, I got in a motorcycle accident, and I never did anything about it. I toughed it out and
Yep.
And that's just the way it was for the next 20 years. And then finally it caught up with me and I couldn't actually climb a ladder anymore at my work, and they made me go have it looked at, so.
Well, it's
You know.
like
And when they fixed it, I felt 100% better, you know.
I wouldn't be able to fly for over 6 months, I wouldn't be able to climb a ladder.
Yeah.
So I said, well, I gotta get my trees done. in
Well, I
the
knew I
yard.
was in trouble when I had to get on a ladder and I could only use one leg to go from one rung to the other, because the other leg hurt so bad I couldn't put pressure on it. So I used to jump from one to the other until I got up there and I'd work with one leg on there, you know. So that's when I knew I was in trouble, you know. I don't know if I'm stupid or tough, I can't tell you which one.
We all get dumb as we
Yeah.
get older, let's be honest.
Yeah.
Did you say?
So, what kind of video you have there? Do we wanna watch that, or do we already watch some of it?
Well, we started to, but we can start it up again.
Are we interested in it? Is everybody interested in the video? Okay, good,
Yeah.
go ahead.
Flight
Start it
190
back.
American Airlines 196,
American Airlines 196 video.
Chicago.
A huge thank you to CuriosityStream for sponsoring this video. The accident of American Airlines Flight 191 took place on 25th of May 1979. But the story of what led up to the accident actually started almost 4 years earlier. On the 30th of May 1975, McDonnell Douglas issued a service bulletin for the replacement of some spherical bearings inside of the aft engine pylon on the wing-mounted engines. Now the DC-1010, which was used in the accident, had 3 engines, one under each wing and one in the back. And the engine pylons, that's the part that's connecting the engine to the wing. The way that it does so is that there are 2 connection points. One in the forward bulkhead of the pylon that's connected to 2 spherical bearings, and then there is a smaller one in the aft bulkhead of the pylon. This first service bulletin was aimed to replace the bearing inside of the aft attachment point on the pylon. But only a couple of months later, another service bulletin also came out with similar content. None of these service bulletins were time critical. This meant that it was up to the airlines to decide when they wanted to implement these changes. Now, removing the engine and the pylon from the wing is a major maintenance undertaking. And American Airlines decided that they were going to implement these service bulletins when they were doing the regular C checks of the DC-10. The aircraft manufacturer, McDonnell Douglas, gave guidance on how to remove the engine and the pylon from the wing. And the way it was supposed to be done is that the first thing you needed to do was remove the engine from the pylon, and then once the engine was removed, you could take the pylon down from the wing. So it had to be done in 2 separate steps. The 3 biggest DC-10 operators in America at the time, which was American Airlines, Continental, and United, they looked at this procedure and said, this looks a little bit unnecessary to us. Why don't we try to remove both the engine and the pylon as one single unit? This way, they could save up to 200 maintenance man-hours, but crucially, they could also remove the number of detachment of electrical wires and hydraulic wires from 79 to 27. And that is actually a safety benefit, because the less connections you have to reconnect and check afterwards, the less is the chance of someone making a mistake or something not being connected.
I'm Coulter. I'm Trent. We are co-founders of Sunday. We created Sunday to create a better future for the American backyard.
Check afterwards, the less is the chance of someone making a mistake or something not being connected properly. The way that American Airlines and Continental proposed that they were going to do this was that they were going to put the engine supported by a freight cradle. These are the kind of cradles that are used to move engines around. And then they were going to use an industrial forklift to carry the weight of both the engine and the pylon while they were being attached from the wing. And once that was done, the whole unit could be moved aside and the maintenance could be performed. United Airlines decided they were going to do this slightly differently. They were going to use an overhead crane instead, but the idea was essentially the same. When American Airlines and Continental, who were both going to use the forklift method, brought this to the attention of the aircraft manufacturer, McDonnell Douglas, McDonnell Douglas representatives had a look at the procedure and they said that, well, we can't really support this procedure because we can see that there are potential issues with the safety clearance between the components inside of the pylon and the attachment points on the wing. But they also said that, well, we can't really stipulate what you, the customers and the operators of the DC-10 is going to do. That's up to your maintenance organization. American Airlines listened to this, but they decided to go with the forklift method anyway. And at the time, there was no need for them to get FAA approval for this maintenance procedure because FAA had delegated a lot of the oversight onto representatives inside of the maintenance organizations of the airlines themselves. When the airlines started to utilize this new procedure that they had come up with, it became very apparent quickly that this was not going to be an easy procedure to do. First of all, it was really important that the forklift was placed very, very exact in accordance with the center of gravity of this whole unit, both the engine and the pylon. If it was not correct, well then the engine could start rocking forth and back and it became very, very hard to actually work on the attachment points. But also the operator of the forklift needed to operate with extreme precision. We're talking centimeters, left, right, up and down. And he could not see himself in what way he needed to move the crane around. So he was relying on hand signals from people who could actually see what needed to be done. On 2 different occasions before the accident flight, Continental Airlines had reported that they had damaged the aft connection point that was connected to the aft pylon bulkhead when they were doing this procedure. But when they reported these damages, they reported them as maintenance errors, as in someone has made a mistake. And because that was done and reported like that, no one really looked into the procedure itself. They just assumed that someone had made a mistake and not that the procedure itself might cause issues. Between the 29th and the 31st of March 1979, the accident aircraft was brought into the maintenance facilities in Tulsa, Oklahoma, to do this engine and pylon removal. From the very beginning, there were some issues during this job. So the night shift started working on removing the attachment points in the forward and the aft bulkhead of the pylon, but they just couldn't get the connections loose. So instead of doing it the way that the work order was supposed to be done by disconnecting the forward attachment point first and then the aft, they decided that they were going to detach the aft attachment point first. When they did that, they created a pivot point around the forward attachment. So depending on how the forklift was moved up and down, the aft attachment point could get into contact with the wing. After the aft attachment point was disconnected, the night shift left and the day shift took over. And when the day shift came, they noticed that the aft attachment point was actually in contact with the wing. And this would indicate that the engine must have moved vertically about 6 inches. As they continued the work, they realized that they still could not detach the forward attachment point on the pylon. And that was because the engine was just slightly misaligned. So what they did was they started moving the forklift a little bit in order to align the engine. And while they were in the process of doing so, the forklift ran out of fuel, so it stopped working. This meant that it was now holding up the whole weight of the engine and the pylon, but without the engine running. We don't know exactly when it happened, but we do know that sometime during this procedure, the aft pylon was pushed up towards the wing attachment clevis, and this caused a stress fracture on the forward flange of the aft bulkhead attachment point. This was not picked up during the subsequent check after the work was finished. The pylon was reattached together with the engine onto the wing, and the aircraft was sent out into service again. During the subsequent 2 months, the aircraft was operated normally online, and it was subjected to the kind of stresses that everyday operation brings to the aircraft. Takeoffs, landings with reverser use and so on. Stresses that the pylon normally has no problem at all solving, but because this part now had a small stress fracture in it, it is likely that this fracture grew bigger and bigger for each day that went by. Before we go into the actual accident sequence, I just have a small message from my sponsor who makes it possible for me to create these type of videos. Now, I know that you guys are watching my videos because you love learning new things and finding out the nitty-gritty nerdy details behind each story. And if that's true, you should seriously check out the sponsor of this episode, which is CuriosityStream. CuriosityStream is a high-quality subscription streaming service with thousands of great non-fictional stories and documentaries from some of the best filmmakers in the world. I am watching a series right now called What Went Wrong, and the last video I saw was the Grenfell Tower fire disaster, which was terrible but also really interesting. If you think, Peter, that sounds really interesting, well then consider supporting me by supporting my sponsor. Go down into the description, click on the link, which is curiositystream.com/mentorpilot, and the coupon code mentorpilot. That will give you a whopping 25% off the annual subscription fee, which is, wait for it, only $14.99 per year, which is insane value for money. Now back to the video. On the 25th of May 1979, this now 7-year-old DC-1010 was scheduled to be used for American Airlines Flight 191, which was a scheduled passenger service from Chicago O'Hare International Airport over towards Los Angeles. And the DC-10 was favored by the airlines at this time for these very heavy trafficked domestic routes because of its great passenger capacity and relatively good fuel consumption compared to the much bigger and fuel-guzzling Boeing 747. In command of this flight was going to be 53-year-old Captain Walter Lux. Now, Walter was a very experienced captain with more than 22,000 hours under his belt. He'd been flying the DC-10 from when it came into the fleet 8 years earlier, and Walter was actually current on, I think, 17 different types, including the DC-6, the DC-7, obviously the DC-10, and the Boeing 727. Very experienced. Walter wasn't really even supposed to fly this flight. He was called off standby to do it. Together with him was Senior First Officer James Dillard, 49 years old, also very experienced, with 9,275 hours of total time, of which 1,080 was on the DC-10. And they were joined by 59-year-old flight engineer Alfred Udovich, who had more than 15,000 hours in total and had been transferred over to the DC-10 about 6 months prior to the accident. The pilots started preparing for the flights. The weather in Chicago was beautiful. There was clear skies, good visibility, more than 15 miles, and a little bit windy. The wind was from 0 to 0 degrees at 22 knots, with some gusts reported as well, which was windy for the time of year, but nothing outside of what we considered normal, and definitely within the handling capabilities of the aircraft. They checked through the tech log as well, but the tech log was clean. There was no maintenance issues whatsoever with the aircraft. The pilots started to board the aircraft. There was 258 passengers scheduled for the flight, and together with the 3 pilots was also 10 cabin crew members. When it came time to do the performance, they got the final weight of the aircraft, which was 379,000 pounds. That's about 172 tons. And based on that, they decided on flaps 5 departure with 5 units of stabilizer trim. And crucially, this is going to be very important, the V1 speed of 139 knots, a rotation speed of 145 knots, and the engine out safety speed, V2, of 153 knots. And remember that speed, because that's going to be very important very soon. At time 14:59, American Airlines Flight 191 started pushing back from their stand and slowly taxiing out towards runway 32 right. First Officer James Dillard was assigned to be pilot flying for the flight, and Captain Walter Lux was going to be pilot monitoring, which means he is the one that's going to do checklist and talk on the radio and so on. At time 15:02, the flight received their takeoff clearance from runway 32 right, which was read back by the crew, and they started rolling down the runway. The takeoff roll was completely normal until only seconds before the rotation. At this point, the pressure on the aft bulkhead attachment point on the number 1 engine on the left-hand side became so great that the forward flange failed, which led to the engine initiating a detachment from the wing. This was confirmed by eyewitness accounts who said that they could see, just as the aircraft was about to rotate, how white mist came off the wing in the location where number 1 engine was. This mist was likely hydraulic fluid from the number 1 and the number 3 system that was being thrown out into the air and being vaporized. As First Officer James initiated rotation, the aft connection of the pylon completely detached. This meant that the full force of the still running engine forced a forward and upward movement of the engine, which pivoted around the forward attachment point before it completely broke loose and flew over the left-hand wing.
Yikes.
When it did so, it also ripped with it about 3 feet of the leading edge of the left-hand wing, and it severed all electric lines, all hydraulic lines as it disappeared. When this happened, there is a final word recorded on the cockpit voice recorder, and that's the first officer, James Dillard, who calls out, "Damn." After that, there's no further recording because the cockpit voice recorder was fed of electrical power from the number 1 engine, which was now tumbling down the runway behind the aircraft. Now, this is obviously a very serious failure. Engines shouldn't detach from wings, but it is still well within the performance capability of the DC-10. Remember, it still has 2 operating engines, and this is also something that the pilot would train for. We are able to handle the aircraft even with a loss and even a detachment of one of the engines. So First Officer James continued to rotate the aircraft off the ground. He rotated a little bit slower than he normally would. This is likely because in a situation like this, where you suddenly have asymmetric thrust happening to the aircraft, the pilots will be very focused on getting the right amount of rudder in order to keep the aircraft down the center line. So he very slowly rotates the aircraft off the ground, gets it airborne, and maintains runway heading straight ahead. Because he rotated a little bit slower, this meant that he is now bringing a little bit more speed than he normally would be into this maneuver. So as he is climbing up the first couple of 100 feet, he reaches a speed of 172 knots. And remember, V2 speed was 153. The way that the flight directors are working, the flight directors, when it senses an engine failure, will give an indication to the pilots to pitch to achieve the V2 speed that they would have set prior to departure. And in this case, that means a pitch of approximately 14 degrees knots.
Redfin learns what you like and constantly finds new homes for you. Want to win? Choose Redfin.
So far, good video.
Set prior to departure. And in this case, that means a pitch of approximately 14 degrees nose up. The problem now is that even though the aircraft has the capability to climb away with 1 engine detached and the pilots are trained to handle it, this particular failure is turning out to be much more complicated than that. Because inside of the now detached number 1 engine sits a generator number 1. That feeds electrical power to several of the aircraft system. When there is a power failure sensed of the aircraft, something called a bus tiebreaker opens up to isolate the faulty system from the rest of the electrical system to protect it. Now, before that bus tiebreaker can be manually closed by the crew after they are verified through a checklist that everything is okay and it's safe to do so, some of these systems are going to be offline. We've already mentioned one of them, that was the cockpit voice recorder, but it also includes systems like, for example, all of the instrumentation on the captain's side, and crucially, both the stick shaker motor on the captain's side and the leading edge slat indicator. So the position indication of the leading edge slats on both wings. And that's really important because of the next thing that is about to happen to this aircraft. The leading edge slats, these are little flaps that are extended on the front leading edges of the wing. They change the overall wing chord and the wing surface in order for the wing to be able to generate more lift during low speed flight. Those are hydraulically operated, okay? They work by hydraulic fluid being pushed in that feeds the slats outwards, and then the hydraulic fluid is captured in the line, it's being kept there, and that keeps the slats from being pushed in by the air load. But remember, the number 1 engine has now completely detached and it's ripped off the hydraulic lines as it did so. This meant that hydraulic fluid that was supposed to be trapped to keep those leading edges out has now vaporized, gone in over the wing. This means that the air load is now pushing the slats in on the left-hand side only. As the slats retract on the left-hand side, the amount of lift that that wing can produce at this speed reduces greatly. And the stalled speed of the left-hand wing increases to 159 knots. And do you remember what V2, the engine out safety speed was? 153 knots. So this means that the pilots who are now following their correct procedure and are pitching up the aircraft, following the flight director on the first officer side, the captain doesn't have any instrumentation, they're now pitching for a speed that is 6 knots lower than the current stall speed on the left-hand wing. The problem is, of course, that the leading edge slat position indicator is also inoperative, so they have no idea that the slats have retracted on that wing. They also cannot see that part of the wing and the engine from the cockpit, and even if they would have, at this part of the flight, they would be concentrating on looking at their instrumentation and controlling the aircraft. So the aircraft keeps climbing, the speed keeps creeping down towards V2, and as the aircraft reaches about 350 feet above ground, the speed drops below 159 knots, and the aircraft initiate a left-hand bank. Now this wouldn't make any sense to the first officer, because he will be looking at this airspeed indicator, and that would indicate an airspeed that is well above the stall speed of the configuration that they have set the aircraft in. So he puts more and more aileron into the right, he puts more rudder into the right, but it doesn't matter what he's doing, the aircraft keeps banking more and more over towards the left. It rolls with about 4 degrees per second over to the left, and as it does so, the nose of the aircraft also starts coming down. And you might ask yourself, what about the stall warning? Shouldn't there be a stall warning that's sounding at this point? And you would be right. The problem is though that at this point, the DC-10 is only equipped with a stick shaker on the captain's side. That loss of engine number 1 has also disabled the electrical current to the stick shaker on the captain's side. So this means that there is no indication whatsoever to the pilots that this left wing has stalled. There is no indication that the leading edges have retracted. There's no stick shaker. There wouldn't even be much buffeting because leading edges on the inboard side of the engine are still extended, which means that the stall is happening further out on the wing, so it's unlikely that it will buffet much. And when I read this, I felt so sorry for the pilots, because they're doing everything right here. First officer has put the correct amount of rudder in, he has rotates nice and smoothly, he's maintaining the track, and he's pitching to maintain V2 speed, which is what he's been trained to do. And still, this aircraft is stalling. If the stall warning system would have worked, well then it's very likely that he, just like any other pilot out there who hears a stall warning, would have pushed the nose forward in order to increase the speed above the stall warning, and that would have led the speed up above 159 knots, where the wing wouldn't be stalled, and it's likely that they could have gotten out of this situation. When this was reproduced in a flight simulator, all of the crews that did get this stall warning actually did manage to control this aircraft. But this crew had no indication whatsoever that this was what's happening to them, and this is what led up to this accident. What led up to this accident. 3 seconds before this aircraft impacts with the ground, the aircraft is in a left-hand roll of 112 degrees and a pitch down of 21 degrees. And a very famous photo was taken from an airport parking lot. And this photo was actually used by the investigation later on in order to determine whether or not the leading edge slats were in or out on the left-hand side, because the damage to the electrical system caused by the engine separation actually also took away some of the parameters from the flight data recorder, including the slat position. Only 50 seconds after the start of this flight, American Airlines Flight 191 crashes into a field 1.4 kilometers beyond the threshold of runway 32 right. All 271 persons on board perish in the accident, making it the worst single aircraft accident on American soil to date. As the aircraft impacts, it is so violent that it completely destroys the aircraft, and the debris is thrown into and destroys an old aircraft hangar, several cars, a mobile home, and it kills 2 more people on the ground. The National Transportation Safety Board investigation starts immediately, and they have 2 main questions that they need answered. 1, why did the engine detach from the left-hand wing? And 2, why were the pilots not able to control the aircraft after the engine failure occurred? They immediately find what's left of the number 1 engine, which is lying on the side of runway 32 right, and they start to look into what part of the engine is still attached to it. Very quickly, they start finding traces of this damage to the aft attachment point of the pylon. And initially, they issue a grounding of the DC-10. Remember, they have no idea that this has to do with a maintenance procedure at this point. They trace the aircraft back to when they did their C-check. They start looking further into this procedure, and they realize that this has happened not only in American Airlines, but also in Continental Airlines. Interestingly though, not in United, who was using this different crane procedure. All of the DC-10s that had undergone this engine replacement procedure was thoroughly scrutinized. In the investigation, they found a further 6 DC-10s that also had very similar cracks that had started to develop in the aft attachment point of the pylon. Once it was established that it was a maintenance procedure that had caused these damages and not the manufacturing, the DC-10 was let back into the air. But its reputation at this point was forever tarnished. This, together with another couple of accidents that happened earlier on, would mean that the general public never really regained any confidence in this aircraft. When it came to the way that the pilots had performed during this flight, the investigators used simulator trials where they let other crews do that flight again under different circumstances, both with and without stall warning. And this, together with the flight data recorder and what they had learned from the accident site, proved that the pilots had performed really well. They had done exactly what was expected from them. No one could have expected them to do anything more than what they actually did. This was an absolutely terrible accident, but as we always do in the aviation business, we use these accidents to become better, to become safer. This accident taught us, for example, that it's really important for maintenance workers to report any problems they have with procedures or any damage they might see, to make sure that that actually reaches the appropriate person so that the maintenance procedure can become safer. It has also become mandatory that before a new maintenance procedure is being implemented, it is being thoroughly looked through and looked for potential problems and threats in it, and that has made the maintenance work in the airline business much safer. This accident also clearly showed that it needed to be mandatory for both pilots to have a stick shaker connected to the controls, and that is now mandatory for all commercial aircraft out there. Now, if you're interested in knowing why the DC-10 had such a terrible reputation among passengers even before this crash happened, then check out these 2 videos that I did about previous DC-10 crashes right now. If you want to support the channel, you can become a patron, it's really appreciated, or buy yourself a t-shirt. Remember the acronym CLASS, and have an absolutely fantastic day.
That was a great video, Lon.
We were always told he was within 4 knots, here it's 6 knots. So, you know, I used to talk to my first officers, and the key is fly the airplane. And you're kind of drummed into the system, even in the military, to do certain things. So you've got an aircraft that's rolling and it's uncontrollable, but you have multi-engines. Are you gonna try and correct it and get the wings level, or are you just gonna let it continue to roll? In my viewpoint, no matter what I was flying, even in the military, if I got that airplane in that's starting to roll, I'm gonna pull the power on the other engine and try and at least walk away from it. If I put it down the middle of the street, I may walk away from it, I may not, but that's my only chance. But they did everything as correct, just like you mentioned there. What happened on this thing is, you gotta figure out the force on that engine. Now, it showed a center wheel, so that means it was a dash 30. It's 54,000 pound thrust engine versus 49.
Were they at full throttle or?
Oh yeah, you're running the end numbers. You may run 107, 109% on takeoff. It's always a percent.
Did they ever retract the gear?
Yeah, that's one of this is positive rate gear up.
But in video.
That's a video.
That's a simulation.
So, you know, whether, but, so I always looked at, my goodness, guys, you know, you gotta fly the airplane, and yet we get drummed in our thing, you gotta do this, you gotta hold this thing, you gotta hold this thing. I can remember when I first went on that airplane, this is what you're gonna do, you know? And it's just like right now, every time you take off, no matter what airplane, it's 10 degrees pitch up. 14's getting pretty high. You know, 14 degrees is pretty high. Where's the stall speed? I talked about this once before here, on an average wing. In fact, almost every wing. The stall speed begins at 17 degrees. And all that individual's gotta do is pop that nose up and you're at 17 degrees and you're in a stall. So, you know, 14 degrees is pretty tough. 10 degrees is the average pitch. And even to this day, you know, my Bonanza single, my glide speed, when I got weight on that thing, 110 knots. It's not 102 and it's not 98 like the book calls for. So if you figure it out mathematically, I'm at 110 to 112 knots for glide speed initially on takeoff with max gross weight. My viewpoint is pop that sucker down, and you gotta be fast on it. Get the nose down, put it where you're gonna get it. If you get it started, good luck. Otherwise, you put it down, gear up. You can put the gear down and see if you can survive a little bit. You'll rip it out, maybe you're gonna spill fuel, maybe you'll have a fire. Well, there's a lot of things that here. The captain was out of Phoenix, and American Airlines had guards in his house for 3 months to keep all the news media away from the family. And it was a 24/7. It was devastating for the whole airline and even for the crews. And you always don't want to lose anybody. We just had someone pass away in the CAP this past week.
A couple of more items before we close up tonight. When you come in to use Redbird for training, log it please, so I know how many hours we have on it, and who's using it, and when. I came in the other day, the little white fan was on, and it got left on somehow, and I'm assuming that somebody was using the Redbird and needed the fan, so they left the fan on, and that was.
Where's the clipboard kept?
There should be actually a log sheet in the.
Oh, it's
Right behind
it's
it.
in the manual.
It should be in there. If it's not, we'll have to make one up.
Well, I looked all over for the
Okay.
quote-unquote clipboard, never found it.
Yeah, if there isn't a clipboard, just get a blank piece of paper and log it in so I know.
Oh, yeah.
And then leave it in the book that's there. Please. So somebody came into the comm room, turned one of the radios on and forgot to turn it off. And I found that on, I can't remember what day, but also we need to make sure that we're not leaving stuff on.
Did that take a key?
Somebody had a key to get in there. I don't know how they got in, but so any of you guys that have keys or know where the keys are, then make sure you check the comm room when you leave to see that everything's off. So
Can I make a suggestion maybe?
yeah,
When we walk out the gate, it says, is your flight plan closed?
yeah,
Remember that? You still got it at Redlands, Civil Air Patrol, Squadron 5 is still at Redlands.
yeah.
We got one here. Put it on the door, you know, where the light switch. Is everything turned off?
Yeah, is
I mean,
everything
it's just a
turned off?
reminder, you know.
Good idea, Bob.
It's just a reminder to maybe it'll save you some equipment repair.
Also, I'd like to thank Andre for cooking last week. He did a great job. The taste was very good. We had plenty to eat that I know of. I was entertaining some new members. Sorry, when I came back, you guys were ready to go. So, but good job. So,
And it reminds us of the old days when we just had hamburgers and hot dogs.
also we have a new pilot. Christopher is our new pilot. He got his check ride last week, and I wasn't smart enough to announce it during Nighthawk, which I should have done, but now I am. So congratulations, Chris.
Thank you.
Gives us that. Also, okay, got the common room. We got
Didn't you buy
everything.
drinks for everybody?
What's that?
Didn't you buy drinks for everybody?
Okay, so one thing I wanted to say is, do we have any questions about the SARX we had a couple weeks ago? I haven't been here and feeling well enough to think about it, so do we have any questions about how the SARX went down? Do we have any suggestions? Do we have any complaints that when we had the SARX at all?
I mean, we talked. I've got an idea about the whole the mission router, the mission kit router.
Oh, well, yeah, for the
Yeah.
internet.
Yeah,
I think we got a solution for that bad internet we had.
well, I mean, first solution is, yeah, I mean, but I think I can make it work so
Yeah.
we give them a port that they can plug into and it'll work just fine.
Right.
Because I know, because all those laptops are,
Again,
they join that
I don't
network,
think we
right?
should plug their system into our system, period. So anyway,
Are those MMK laptops, are those only Wi-Fi for the MMK's router?
correct.
Yeah, so that's why I wanna make that work without disrupting our
The
network.
the MMK laptops talk to the MMK router.
Yeah,
The MMK router's wireless by a card that they plug in.
oh,
and-
it's cellular?
Yeah,
Oh.
it's
okay.
not, it's
Okay.
not supposed to be connected to us. It's got
But,
its
but
own
somebody
cellular
did
card.
connect it to us.
Huh?
Somebody did connect it to us. and
That's right,
what
somebody
got-
did, because
okay,
when I
okay.
disconnected everything, I saw the cable going from their
Okay.
router to our router.
Okay.
And I mean, our router to our switch, and I go, well, that's
See,
why
I
everything's
didn't
been
get a good
messed
look
up.
at it, so that's a cellular
I didn't
router.
plug it in, so, but
So-
I did unplug it.
So that's a cellular router, okay.
That's a cellular router,
Okay.
and it's meant to be all set up, ready to go, so that if they wanna take it out to, you know, I don't know, Arrowhead, and they can plug it into a generator, and it's supposed to work.
Okay.
So, now the printers that were here, those
Yeah.
are on the same Wi-Fi system. You just plug the printer into a 110 outlet and it talks to the router, it's all set up, it's all plugged in. Everything's supposed to work when you plug it in and turn it on. We had a problem because somebody stuck a cable in theirs and a cable in ours, thinking that they should be linked and they shouldn't have. Right? Because it's two routers trying to create a DHCP address to some item, and
Well, it also jacked up our internet, so
Yeah.
that's what I restarted.
yeah. And the reason why I know is because somebody said something about, hey, it says that this IP address already exists, and I was over here busy doing something, and I didn't finish that thought. If I would have finished the thought, I would have automatically known, but when I came back, so it's in my head, anyway. So anything else on the SARX that we need to talk about? All right,
Was
so
it-
let's adjourn the meeting.
Was that a pretty normal SARX, or?
Well, actually, pretty normal, yeah. It didn't go so bad. I mean, it could have went better, could have went worse. So it was pretty normal. We had one AOBD, which was Jim. He controlled everything pretty well. It didn't go as well as he thought it should, but he was in control of everything. I was a backup AOBD in case he got swamped, so.
And that was it Major Kumar's, like, he was still IC training, right?
Yeah, he was the IC trainee, and Mr. Newton that was here, Colonel Newton, he was the IC of record,
Okay.
and he was training Kumar, so. And he also was trying to train Ben in the back, and since I didn't really have any position, I didn't really have to talk to anybody, so I was just here as a liaison. So,